Hey everybody, welcome back. So we're going to start lesson 3.5, solving logarithmic equations with the one-to-one property. If you've been working right along, you know that we've already solved exponential equations with the one-to-one property. So this is going to be very, very similar in some ways. Other ways it'll be different. Essentially, the one-to-one property means that if you have matching logarithms on both sides of the equal sign, they cancel. And once they cancel, you do regular algebra like you've always done. Now, when they do cancel, the result could be linear, which is fairly simple. Just work it out, solve it, good to go. Or quadratic. Quadratic means that there's x squared in it. And all through Algebra 2, you've solved quadratic equations. There's something called the quadratic formula. You won't need that for this, but there's other methods. Keep in mind, quadratic equations usually have two solutions. It is possible with logarithmic equations that only one solution will work, or sometimes no solution. So you'll work out a whole problem and you'll get two solutions, and it turns out that one or both of them are extraneous. They don't work. And so the way to figure that out is to plug them back in and check. Now, how could that happen, you might wonder? So I have Desmos pulled up, but I'm about to sneeze. Forgive me for just a second. Okay, I fought it back. It was almost a sneeze. Sorry about that. Real professional. Anyway, I've pulled up Desmos to show something about logarithms. So let me just do a general random log. So I'm going to do logarithm base 2 of -8. Oops, no, not 2 minus 8. Logarithm base 2 of -8, and you get undefined. Or maybe the natural log of 0, and you get undefined. You can only take logarithms of positive numbers. That means that sometimes when you get an answer, you go and plug it back in, it won't work because the result is negative. I'm not saying negative answers are always wrong. You can still get negative answers because sometimes when you plug them in, they turn positive, and that's okay. But there are times where no matter what you do, you get your answers, you feel like you did all the math right. When you plug them back in to check, they still fail to work. So that's something toward the end of the examples we're going to deal with. If you're the type who watches one example and then shuts it off and gets to work, keep in mind that when I get to the end, they'll get more complicated. See, if you look at that, that looks really complicated. And we may end up with scenarios where there's no solution, or maybe only one or two solutions work. All right, I don't really need Desmos right now. I'm going to move it out of the way and get into examples here. So, as normal, I'll do the evens, you do the odds. Number 2, we have log base 20 of -3v equals log base 20 of v plus 8. And the one-to-one property, basically there's one logarithm on this side that cancels out with one logarithm on that side. As long as they're the same, if this one over here was log base 5 instead of log base 20, then this wouldn't work. You couldn't solve that equation with what I'm teaching you today. You'd have to use other means that we're not going to worry about. But the point is, they do cancel out, and you get -3v equals v plus 8. To solve this, pretty straightforward. We'll subtract v on both sides. -4v equals 8. Divide by -4. You get v equals -2. Now right here, we've done all the steps right. We have a negative answer. And you might worry, okay, Haskell said you can't log a negative number, so that must mean that there's no solution here, right? Well, not exactly. If we plug this back into the original problem and try to check it, what happens? Well, here we have a negative times a negative, which equals a positive, so that becomes log base 20 of 6. And then on the other side, -2 plus 8. -2 plus 8 is also 6. So even without a calculator, log base 20 of 6 equals log base 20 of 6. These are positive numbers. Even though the answer was negative, when you plug it in, it turns positive. So it's a good, legit answer. Everything about this problem is fine. In fact, when I set up here that results may be linear, that's what this is. Linear means that their x does not have any exponent on it, or the variable, in this case v. If it was v squared, that'd be quadratic, but it's v. So when you have a linear problem like this, just regular variables, no exponents, your solution will be the solution. I'll go down and check this, and it is good. Wait, here it is, right here. You notice the whole no solution thing doesn't really creep up toward the end of the worksheet. All right, let's do another one. If you get this, you can fast forward to some of the later problems. All right, so log base 4 cancels with log base 4. 3n equals negative 4n plus 6. Add 4n to both sides. 7n equals 6. Divide by 7. And you might not like this. Oh, 7 doesn't divide into 6. I hate fractions. Well, you just have to deal with it. There is a fraction answer on this problem. And it is going to happen more and more as you do these this type of math. So there it is. So fraction answers are sometimes decimal answers. Not on this worksheet, but that can happen. So 1 and 3, the odd problems you're going to do, are the only ones that are linear. Look at all of the x's. They do not have powers or exponents. So they're linear. They're going to work out nice and perfect, just like 2 and 4. Some of the rest will work out nice and perfect, but others will give you extraneous solutions. And if you recall, extraneous comes up before. The main part of extraneous is the word extra. They're extra solutions that don't actually work. Not saying it's going to happen on number 6, though. So let's do this. The one-to-one property says we can cross out log base 11, or cancel it. And we come up with this. Now, when you solve a quadratic, the most important thing is to have ax squared plus bx plus c on one side, 0 on the other. And then you can probably factor this side and set it equal to 0 and work it out, something like that. So we want all of the terms on one side of the equal sign. I'm going to go ahead and minus 2n squared. So I get 40 equals, what is 3 minus 2 is 1n squared. Bring down the minus 3n. And then subtract 40 to bring it over here. And you can probably shortcut this. I believe many of you are going to be just fine utilizing some sort of shortcut to rewrite this. But now we have a 0 on one side. It doesn't matter whether it's on the right or the left. If you like it better like this, oops. So be it. I mean, as long as the 0 is on one side, it doesn't matter if it's on the right or the left. That doesn't make a difference at all. So we get this. Okay, so now let's factor. N times n. What multiplies to 40 and adds up to negative 3? Now that seems like a stretch. So 4 times 10, that's not going to work. 5 times 8, duh. Negative 8 plus 5 is negative 3, isn't it? So now if we set each one of these equal to 0, we get n equals positive 8, because you're going to add that over. If you subtract this over, n equals negative 5. So I come up with 2 answers, 8 and negative 5. I'm going to go ahead and check myself first. And if it's good, we'll just move on. And there it is, 8 and negative 5. Now, why did I say check myself first? Because sometimes you get 2 answers and only one of them is right. Or sometimes you get 2 answers and none of them are right. So that will be coming up here in just a minute. Here we go. So again, this is quadratic. There's a second power here. And you can have these with third, fourth, fifth power. We don't do that in this class, but in math it could happen. So log of negative 5p equals log of 24 minus p squared. Notice there is no base on the logarithm. Just for review, when there's no base, it is technically base 10. Again, that's called the common log. So you should know that's what that means. It's irrelevant here because we're just going to cross it out anyway. I just wanted to review the concept. So anyway, crosses out 24 minus p squared. We want everything on one side, 0 on the other. I also don't like negatives in front of my squared term. So I'm going to add p squared. My gosh. I got to keep track of what I'm doing. Add p squared to both sides. And just to make it streamlined, I'm going to minus 24 also. Hope this isn't too sloppy of a way to do it. So these cross out, I get equals 0. On the other side, I get p squared, which is positive, minus 5p minus 24. So there, I kind of combined some steps together. Factor this, p. Now, what multiplies to 24 and adds up to 5? Oh, geez, it's just like the last problem. It's 8 and 3. That's just a coincidence. Negative 8 times positive 3 is negative 24, and it adds up to 5. That was just... Oh, the other one was 40, but still 8 times 5, 8 times 3. It wasn't the same. I'm dumb. Okay. Anyway, okay, so set this equal to 0 and solve this. So add 8 over to that side, p equals 8. Subtract 3 over to that side, p equals -3. And so I get 2 answers. But now I need to go back up and check those answers. I've already peeked at the answer key, so I know something is fishy. So let's start with -3. In fact, you know what I'm going to do? I'm going to bring Desmos into the picture. So this is a common log. Let me do it this way. Okay. So I'm going to start with plugging in 8. I'm going to plug in, an 8 here and an 8 here. So function log, I use the common log button, -5 times 8. It says undefined. I don't even need to plug it in here. I already have this giving me undefined. So I know that is an extraneous solution. Now I'm going to pretend like I didn't see the answer key and I don't already know that -3 is the answer. Let's plug in a -3 here and here. So back the truck up and make this a -5 times -3. And I get 1.176. Now I'll do the other side. So that's log, function log 24 minus parenthesis -3 parenthesis, back up, and then squared. Oh, that's supposed to be 24. Smart guy. Okay, and you see the exact same answer now. So I plugged it into both sides. I used the calculator. I could have sort of worked this out manually. That would have been okay, but I got a calculator. I'm going to use it. You get the same answer, so that means that this is a good solution. So now I would go down and check my answer. Number 8, okay, -3 is the answer. There are not 2 answers. So if this were a test, you would not have the luxury of looking the answer before you start and knowing ahead of time that something was going to fail. So it's up to you to plug these numbers in to see if they fail or one does or whatever. So I believe number 10 was a no solution. We kind of know ahead of time. Let's just play dumb. For me, it's easy because I'm kind of dumb sometimes. Anyway, we'll play dumb and we'll just see, we'll assume we don't know anything about this problem. So I'm going to use the one-to-one property, cross out log base 14 on both sides. I come up with this. I need a 0 on one side, so I'm going to add 3k squared, and I'm also going to add 10. I'll do it all in one shot to make it go a little faster, so I get a 0 here. Okay, -2k squared plus 3k squared is 1k squared. Bring down the -7k and bring down the plus 10. And that doesn't really look like a 10. If someone wants to look at these notes later, there we go. Okay, so now I factor this. K and k. I need 2 numbers that multiply to 10, add up to -7. I believe that's going to be -2 and -5. They multiply to 10, they add up to -7. Set each one equal to 0, which you could probably do in your head. K equals 2, k equals 5, and you're like, okay, here are my answers. Then you have to go back and check and see, are they really answers? So function log base a of 14. I'm going to start by plugging in a 2 here and here and then here. So -2 times 2 squared minus 7 times 2. And already I get undefined. So that is a bad answer. I don't even need to plug it in here to check. Undefined is undefined. It's no good. So 2 is extraneous. I cross it out. Now I need to do the same thing with 5. Plug it in here and here. Well, I'm going to make my life easier and change these 2's to 5's. And again, undefined. There we go. Now let's say this wasn't undefined. Let's say it worked out to give you an actual answer. Well, you'd still have to plug it in here to double check. So just for the sake of thoroughness, I'm going to do that. -10 minus 3 times, doggone it, minus 3 times 5 squared. Well, and as you can see, that one's also undefined. Did I need to do that? No, I already knew it was extraneous. I just wanted to go through the work just to make sure. So number 10 turns out to be no solution. And if we scroll down, just as we expected, no solution. Let's look at number 12. Again, these just cross out. 56 minus 3p equals p squared minus 4p. I'm going to go ahead and add 3p to move it over to this side, and minus 56 to get one side equal to 0. Negative 4 plus 3 is negative 1p minus 56. Factor this, p, and then 7 times 8 is 56. Positive 7 and negative 8 will add up to negative 1 right there. So that is that. Set each one equal to 0. And on one you get negative 7, and on the other you get positive 8. So if this were a test, you might have multiple choice, right? Choice A is negative 7. Choice B is 8. Choice C is negative 7 and 8. And choice D is no solution. So on a test, you don't have an answer key. You can just scroll down and check it. So what do you need to do? You need to plug these in. Use Desmos if you have to. Plug them in and check it out. So I'm going to put a negative 7 here, and here, and here. So function log base 3. 56 minus 3 times negative 7. Nope. Gosh. 3 times negative 7. So 2.965, blah, blah, blah. Now I'll do the other side. Log base 4 of parenthesis negative 7, close parenthesis squared. Remember, when you square a negative, you need to put it in its own set of parentheses, not counting the parentheses that belong to the logarithm. And then, ooh, that doesn't look good. Did I type this? Oh, it's log base 4, not log base 3. I don't know where I got that 3 from. There we go. No, it's still, what? Oh, and then that's 56. Good grief. Holy cannoli. If you type stuff in wrong, guess what? It doesn't work. So, I typed stuff in the calculator wrong. I think it's the stylus I'm using. I'm hitting the wrong buttons on the keyboard. I am sorry about that. Anyway, I plugged in negative 7 and it worked. So this could be the answer, or that could be the answer. Now we need to check 8 and see if that works. So I'm just going to go back up here and change these all to 8, which means on my calculator, take out that negative 7 and make it an 8. Take out this negative 7, make it an 8. And then that negative 7, make it an 8. Not a negative 8, just 8. And we get the same answer, 2.5. So, negative 7 and 8 would be the correct solution. And if you check it, there it is. Okay, so your homework, obviously the odds. Now, just because 10 was a no solution does not mean that 9 is going to be a no solution. I didn't make it that obvious, but there are similar problems on here. So please do the odds, check yourself, but also do the, plug it in to check yourself, not just scrolling down to check yourself. Make that something that you can do, because when you take the test, you will not be able to just scroll down and check yourself. So yes, I'm asking you to do a little work you probably don't want to do when it would be easier just to scroll down. On a couple of problems, I want you to do that. As always, show your work. So I expect to see steps written out. You don't have to do everything exactly like I do, but if you just have answer, 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 I'm not going to count it. So keep that in mind. Contact me if you have questions, and I will talk to you later.